Well, welcome back. In this section, we're going to continue to work through some geometry topics, and specifically the Pythagorean Theorem. I'll bet you remember the Pythagorean Theorem. It's one of the most famous formulas in mathematics. It says that if you have a right triangle whose side lengths are A and B that form the right angle, then we can square those and we'll always end up with C squared, where C is the longest side of that right triangle, which we call the hypotenuse. So stated another way, that means that if we have the two sides, which we call A and B, and square them, that is to say, build squares off of their sides, then the areas of the red and blue square that you see here have to add up to the area of that purple square. And that is the Pythagorean theorem. But the key is, and most mistakes are made, and that we have to correctly label what sides A, B, and C are. So A and B are what we call the legs of that right triangle. And they're typically identified with a little box that indicates that they are forming a right angle. Now, for our purposes, if a triangle looks to be a right angle, but it doesn't have that box, we'll assume that it is a right angle and give it the benefit of the doubt. But that box verifies that that's a right or 90-degree angle. C always has to be the hypotenuse, the longest side, the one that does not touch the right angle. Now A and B can be switched, but I always like to make A the shortest side and B the longer of the two sides that are forming the right angle. But C always has to be longer than both. And that gives us a simple way to check our answers sort of intuitively when we're done solving. We can compare A, B, and C and make sure that they fall in that order. And usually if we've made a mistake, we'll spot it then. There's lots of different proofs of why the Pythagorean theorem works, but here's one of them. As we noted in the last slide, we could build a square off of A and a square off of B, and those squares have to add up to a square off of side C. This little graphic shows that. A square off of side C, that large black square, gets moved around into two smaller squares, where the two smaller squares are built off of the two shorter sides, A squared and B squared. So just sliding these two gray triangles around, you can see that A squared and B squared, that area is the same as C squared. So let's take a look at an example. In this truck, we have a drive shaft that forms the hypotenuse of a right triangle. And if we measure straight back horizontally, we have 43¼ inches, and then straight down from there vertically, we have 10½ inches. So 10½ and 43¼ form our two legs. We would like to find the length of the drive shaft or the length of the hypotenuse. So let's do that. Well, the first thing we have to do is make sure that we label the sides A, B, and C correctly. So definitely that 10½ is our shortest side. We're going to call that A. 43¼ is our other leg. We're going to name that B, and that means that the drive shaft, the side that we're looking for, is going to be C. So we know, of course, that A squared plus B squared is going to be equal to C squared. So let's fill in the values we know, and we're going to write those as decimals. 10½, our A value, is 10.5 squared, plus our B value of 43.25. And that's going to be squared, and that has to equal C squared. Now, when you type these into your calculator, make sure you're squaring them and not just multiplying them by 2. So 10.5 times 10.5 turns out to be 110.25. Make sure you're getting that value. You might also have a squared button on your calculator like this one. So 43.25 multiplied by itself or squared turns out to be 1870.56. We don't need quite that many decimals, so 2 decimals will be fine for our work with the Pythagorean theorem, 1870.56. Those still have to add up to be C squared. So our next step would be to combine those. And when we add those, we get 1980.81. You can verify that on your calculator. Now, to figure out what C is, we need to unsquare that. Some number squared gives us 1980.81. That's what the square root function does. It unsquares. So we want to unsquare 1980.81. So find that square root button on your calculator. It varies a lot as to where that's found. On my calculator, it's right here. I'm going to take 1980.81 and take the square root, and it turns out to be 44.51. Those are inches in this problem, and that is the length of side C. And we're done. And that should seem about right. In our picture, we'd need a drive shaft definitely longer than 43 1/4, and that's exactly what we got. Okay, I'd like you to do this one for practice. Just a plain old diagonal piece of plywood. One way to check and see if you're a large rectangle, like even a garage foundation or a piece of plywood is nice and square, is to see if it satisfies the Pythagorean theorem. This plywood is 36 1/2 inches by 78 1/4 inches. So knowing that those are your two side dimensions, use the Pythagorean theorem to figure out what the diagonal measurement is, or the hypotenuse, in that right triangle. You go ahead and do that and unpause when you're ready to see the solution. Okay, well, first of all, 36 1/2 must be our shorter dimension, and 78 1/4 is the longer dimension on that plywood. C is the diagonal measurement across, the hypotenuse. A will be 36 1/2 and B is 78 1/4. So I think we should all agree on that. And now we can apply the Pythagorean theorem. So here again, we know that a squared plus b squared has to equal c squared. Let's fill in the values we know here. A is 36 1/2. We're going to call that 36.5. B is 78 1/4, so 78.25. Now we can square those. I'll trust you can do that on your calculator. 36 1/2 times itself gives us 1,332.25. 78.25, when we square it, gives us 6,123.06. And that adds up to c squared. Now, let's go ahead and combine those. 1332.25 plus 6123.06 gives us a total of 7455.31. That's equal to c squared. Now, again, to figure out what c is, we're going to take the square root of that. The square root of 7,455 is what we'll get for a value of c. And if you do that on your calculator, the square root of 7455.31 turns out to be 86.34, and again, 2 decimals is fine there. And so that means that the diagonal length on that plywood should be 86.34, and again, those are inches. About 86 3/8 if we wanted to measure that with a tape measure. That's what you should get. If you didn't get that value, you might want to rewind that and double check to see if you can find what went wrong. Okay, both of the examples that we just did, both this plywood example and the drive shaft example, it was the hypotenuse that we were looking for. We knew A and B and we were looking for C. Here we knew A and B and we were looking for C. But that's not always the case. We can find A and B as long as we know what C is. So let's take a look at one of those cases. Here's a triangle. The lengths of two sides are given in yards, but this time we know the hypotenuse. 10.75 is our hypotenuse, so that would have to be our side C. 8.6 yards is given, and that side looks longer than the other leg, and so A will be the side that we don't know. B is the 8.6, that's the longer leg that we do know, and C is our hypotenuse, which we do know. So it is certainly still true that a squared plus b squared is equal to c squared. But our known values are going to slip into different spots here. We don't know a, so that's just going to remain a squared. B, though, we do know is 8.6, which we'll square. And this time we do know c, which is 10.75, and that's going to be squared. So we have a squared, which we can't do anything with. 8.6 squared, yeah, we can square that. On your calculator, you can verify that that's 73.96. Equals 10.7 squared, that's 115.56. Now, here's where things look a little different. We want to figure out what a squared is. We would like it if that weren't there. That 73.96 should go away so that we can take the square root. So we have to subtract that off. Anytime we're looking for a and b, we won't add our a and b's together because we don't know them like we did before. Instead, we subtract off, in this case, b squared from both sides. And if we do that, we get a squared equals 115.56, that's c squared, minus b squared, and that leaves us with 41.60. And now we can finish that out as before. If a squared is equal to the difference, 41.60, then a must be equal to the square root of 41.60. And you can take that on your calculator to get 6.45 yards. And we can compare that to our picture. A is definitely the shortest side. It should be smaller than 8.6, and it is. 6.45 looks just about right. Now notice that this question says, then find the perimeter. So we can do that based on our earlier work. We know that the perimeter is simply the total distance around. And so our perimeter is going to be the sum of these three sides. A, which is 6.45 yards, plus B, which is 8.6 yards, and C, which is 10.75 yards. And if we add all those together, we end up with our perimeter, which is 25.8 yards. So you're going to have some questions of that type in your practice problems for today. Make sure that you read the instructions and answer for the missing side or the perimeter accordingly. Okay, one more. I'd like you to do this one for practice before we wrap this up. Typical gable roof on a garage like this one forms a right triangle, and there's actually a lot of Pythagorean theorem used to build the roof on a house. I would like you to figure out what the height of this triangle is. The overall width of that roof is 28 feet, and the face of the roof is 16.75 feet. So I'd like you to figure out the height. Now note that 28 is not the side of this triangle. 28 is all the way across the roof, so you're going to need to take that into account. All right, go ahead and do that and unpause to see the solution, and we'll wrap this up. Well, if the total width of that roof is 28 feet, then apparently the bottom edge of our right triangle found in that roof must only be half of that, or 14 feet. And so A would be the height. It looks like that's the shorter value. We'll call that our unknown A. B is 14, and C is 16.75. Then here we go. A squared plus B squared is equal to C squared. Rolls right off the tongue. We don't know A in this case, so A squared plus our B value of 14 squared is going to equal our C value of 16.75 squared. So that means A squared plus our B value of 14 squared, that's 196, has to equal 16.75 squared, which is about 280.56. You can verify that on your calculator. We want to get the A squared by itself, so we're going to subtract off that 196 that it's with. And when we do that, we get A squared is equal to 84.56 after we subtract those two. Which means our value for A must be the square root of 84.56. And if you do that, A turns out to be about 9.20 feet. And this question doesn't ask us for the perimeter, just the height of that triangle. A is 9.20 feet. And if we take a look at our picture, yeah, that looks about right. It's certainly not as long as side B, which would be 14 feet, so we got it. Now, if you didn't get 9.20 feet, go back and watch that again and see if you can find your error and spot what went wrong. Okay, well, that wraps up this topic, a nice short little topic there. You can write the formula A squared plus B squared equals C squared on your conversion sheet. That's one that we'll be using periodically. That is the only goal of this topic, was to be able to apply the Pythagorean theorem to several different types of triangles, and you can now do that. So we'll continue working with another geometry topic of area in our next lesson, and we'll see you then.